Section 6.7 is polygons in the coordinate plane. So you're going to need a calculator and graph paper. So pause the video and go get that stuff and come on back. Okay, so we're going to look at polygons in the coordinate plane. We have three formulas to review. So we're going to use these three formulas to classify figures. The first is the distance formula, and we're going to use that to determine whether sides and diagonals are congruent. And the distance formula, see if you can figure it out for yourself. Pause the video. All right, so the distance formula is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. That's the distance formula. You need to know it. Okay, the next one is the midpoint formula. Again, pause and see if you can fill that in for yourself. Okay, the midpoint formula is x sub 1 plus x sub 2 over 2, y sub 1 plus y sub 2 over 2. We've been using that in Chapter 5 to find circumcenters and things like that. We're going to use the midpoint formula to determine the coordinates of the midpoint and to determine if diagonals bisect each other. And the last formula is the slope formula. This one you should know. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we're going to use that to determine if opposite sides are parallel and to determine if diagonals are perpendicular. So let's do a couple. The first one we're going to look at is to classify a triangle. So to classify a triangle, and we're going to classify right now as scalene, isosceles, or equilateral. And scalene means none of the sides have the same length. Isosceles means two of the sides have the same length. And, equilateral, what's an I? Equilateral means that all three sides have the same length. So I'm going to look at this triangle. Point A is going to be 0, 1. That's going to be A. B is going to be 4, 4. And C is going to be 7, 0. 1, 2, 3, 4, 5, 6, 7, 0. And that's point C. All right, so I want to know the distance of the three sides of this triangle. And that will help me determine if it's scalene, isosceles, whatever. So using the distance formula, let's do the distance of AB first. So x minus x, 4 minus 0 squared, plus y minus y, 4 minus 1 squared, is going to equal the square root of 16 plus 9, which is the square root of 25, or 5. Okay? BC. We're going to take the square root of 4 minus 7. That's x minus x squared. 4 minus 0. So that's going to be the square root of, that's 3 squared, that's 9. 4 squared is 16. That's also the square root of 25, or 5. So we know at least it's isosceles. It's not scalene because it does have two congruent length sides. So let's look at AC now for our final one. AC, x minus x, square root of 0 minus 7 squared, plus 1 minus 0 squared. That's the square root of 49 plus 1, which is the square root of 50. Really doesn't matter what that equals. We can simplify it if we want to 5 root 2, but it's clearly not equal to the other two sides. So we have determined that this is an isosceles triangle. So classifying a triangle by side lengths using the distance formula is one of the ways we're going to do problems in this section. Let's look at another example. Is parallelogram ABCD a rhombus? Okay, And we're going to label this A is going to be at -2, 0. B is going to be at 0, 4. C is going to be at 4, 5. 2, 3, 4, 5. Oh, come on. 4, 5 is going to be point C. And D is at 2, 1. And the question is this a rhombus? So think about the ways that we can determine a rhombus. We could do the distance formula for all 4 sides and make sure that they are identical. Or we could make sure that the diagonals intersect in a right angle. And I think that's going to be the easier one to do. The distance formula takes a little bit more work than a slope does. So I'm going to look at the 2 diagonals. I'm going to find the slope of AC, which is 5 minus 0 over 4 minus a -2, or 5/6. Then I'm going to take the slope of BD, and that's going to be y minus y again, 4 minus 1 over 0 minus 2, which is 3 over -2. And what's the rule to determine whether or not these are perpendicular? Well, the slopes have to be opposite reciprocals. We can see that 5/6 and -3/2 are not opposite reciprocals. Therefore, this is not a rhombus. Okay? So again, we could have gone about this with more work. We could have shown that the 4 sides were parallel, doing the slopes of the sides. We could have looked at the side lengths to see if they're all the same. But the quickest thing to determine on a rhombus is that the diagonals have to be perpendicular. Okay, let's try one more example together. Stick with me on this one. Don't quit. So classifying a quadrilateral. We are going to draw a kite. We have kite A, B, C, D. Oops, they called it KITE. So K was at -4, 0. This is K. Point I is at 4, 0. Hold on, I'm counting to make sure I have this right. Yes, at 4, 0. 1, 2, 3, 4, 0. That's I. T is at 8, 0. 1, 2, 3, 4, 5, 6, 7. Whoops, but it's out here, 8, 0. That's T. And E is going to be at -4, 0. Whoops, these are 0. Goodness gracious. 0, 4, and 0, -4. Okay, and that is a kite. They've told me that in the given. And the question is, what's the most precise classification of a quadrilateral formed by connecting the midpoints? So we want to classify the quadrilateral formed by the midpoints. Okay? So first I've got to find the midpoints, and then I've got to check on the quadrilateral that forms. So the midpoint of KI is 0 plus a -4 over 2, and 0 plus 4 over 2, so -2, 2. So there's the midpoint there. The midpoint of IT is going to be 0 plus 8 over 2, and 4 plus 0 over 2, which is going to be 4, 2. 1, 1, 2, 3, 4, 2. And if we continued in this manner, we would get 4, -2, and -2, 2. So the question is, what kind of quadrilateral is formed by those midpoints? Now, we got pretty lucky on this one because these are all horizontal and vertical lines. So I know that these are 90-degree angles. And all I need to do is check distances. It's pretty clear here. And if I label this -2, 2, and label this 4, 2, the distance along the x-axis, since there's no rise here, it's just run, is -2, or 4 minus a -2, which is 6. The same holds true down here. And then my vertical distances are 4. So I got lucky because they were horizontal and vertical lines, which made it very easy to determine that they were perpendicular to each other. And then when I found the distances of the sides, I can clearly state that this is a rectangle. And that's the most precise name I can give it. So we're going to have all kinds of problems where we are looking at different polygons on the coordinate plane and then determining by use of either distance, midpoints, or slopes, or a combination of those, what kind of polygon we have. That's it.